Okay, my name's John Valley. I'm the National Manager for Severe Weather Services in the Bureau, and I'll be talking to you about the outlook for the current season or for the coming season for bushfires, tropical cyclones and severe thunderstorms. Okay, so the aim of the Severe Weather Service is to support community resilience by providing people with the information that they need to make effective decisions when severe weather threatens. We do that by providing timely and detailed warnings of severe weather. And we do those as accurately as we possibly can, given the limitations of the state of the science and the capability that we have available. And we produce a range of products to deliver that service. We've got seasonal predictions like the one that we're doing today, and there'll be a more detailed tropical cyclone outlook issued on the 15th of October. But more routinely, we produce forecasts which are updated every 12 hours, warnings which are updated every 6 hours, and then more and more frequently as severe weather impacts are getting closer and closer, down to hourly for tropical cyclone warnings just before landfall, and observations which are pretty frequently updated as well. We've got an extensive radar network that runs at, or most of it runs at 6 minute scans, so 6 minute updated radar observations of severe weather and rainfall, and other observations more frequent than that. Now, the fire seasons vary quite a bit from one part of the country to the other. Up in the tropical north, we've got more of a winter and early spring fire season. As you get further south, the fire season tends to get later, more in the southern summer, the sort of dry southern summer, down to midsummer and even late summer in the far south. And the Fire Weather Service is a bit of an unusual one for the Weather Bureau because it doesn't just depend on the weather. It doesn't just depend on the temperature, the wind and the humidity and the rainfall. It also depends on the fuel state, which you have to include in the calculations so that you produce a range of fire weather products, including fire danger indices and fire danger ratings. Well, Bureau does the first cut fire danger ratings. We produce a lot of detailed information from those and a public fire weather warning. The agencies use that information and add their own risks to that, like the availability of firefighting resources and particular vulnerabilities and so forth. Now, with the next generation forecast and warning system that we're rolling out across the country, that's in Victoria, Tasmania, New South Wales and South Australia at the moment, and it's rolling into West Australia in October. We produce really detailed fire weather information, so that's an example of a fire danger index and rating forecast of Victoria. You can see the level of detail down to 6 kilometre resolution. Some of that's daily products, like the maximum for the day, out 4 days ahead, and some of it's even hourly resolution. Now, as Gary was saying, over the last couple of years we've had 2 La Niñas, so the country's been quite wet. In fact, we've had the wettest 2-year period on record, and that's really put a dampener on fire activity through large parts of the country, particularly the southeast. And this graph shows the number of fire weather warnings that the Bureau's issued through southeastern Australia over the last 10 years. And you can see these last 2 years, 2010 and 11, are real standouts as years of fairly low fire activity, particularly in New South Wales and Canberra and Victoria, where we've had really quite mild fire seasons for the last 2 years, basically due to the wet conditions with the La Niña. Now, over here we have the satellite vegetation index, which can be a bit of a difficult thing to interpret. It's a bit of a complex thing, but basically it shows you how much growth there has been in the vegetation, and you can see that this is the anomaly over the winter and early spring period, and there's been more growth than average. Green means more growth, so we've had growth of mainly grassy fuels in large parts of the country that normally don't get a lot of growth. I think they were trying to make a movie there last summer and expecting desert conditions, and it didn't really work out too well because it was too green. Moving through to the rainfall over the winter-spring period, it's been quite dry over particularly the western parts of the country, South Australia, and in a band through to the Murray-Darling. So those dry winter conditions combined with the growth that we've had over the last 2 years and including the last winter has meant that there's quite heavy fuel loads over large parts of inland Australia, and those fuel loads are curing. So that gives us a significant fire threat from those grassy fuels. Now, thinking about the forest fuels, this is a forest drought factor, which is an indication of how flammable forest fuels are. That's again another product from the next generation forecast and warning system, and you can see the areas that that's running for at the moment. West Australia will be included in a few months' time. Green means fairly wet, yellow means fairly dry. And this really only makes sense in those forested areas like southeast South Australia, much of Victoria through the New South Wales highland areas and a lot of Tasmania. And those conditions are quite green, quite wet. So forest fuels are generally not particularly available for burning at the moment. Though of course it only takes 60 days or so to go from quite a wet state to quite a dry state in forest. So that gives us some comfort in the forest fuels through to about the new year. After that it could be a different story. Now I'll just point out a couple of things here. We've got some drier areas along the New South Wales coast, and that's indicative of the fact that that's more a spring fire season rather than a summer fire season, so you'd normally get that drying this time of year. And eastern Tasmania, where there's a pocket of forest fuels there that's again not unusually dry for this time of year. In fact, that pocket on the east coast of Tas tends to be dry the whole time. Now going through to the outlooks for spring and heading into summer, we've got those two maps that Gary showed you. These are exactly the same as Gary's. We've got above average probabilities of wet conditions in much of West Australia and parts of southwest Queensland. But remember that these wetter areas are areas where we don't get a lot of summer rainfall anyway. So, even though they're green, that's not necessarily going to give us a lot of relief to the fuel conditions in those areas where we've got a risk. On the other hand, that Indian Ocean dipole is giving us higher probabilities of dry conditions over that southeast South Australia, Victoria and Tasmania area, and that's a cause for some concern, particularly since the temperature outlook is for high to very high probabilities of above average temperatures. That's a bad combination for fires. Now here we've got the seasonal bushfire outlook. That's produced as a cooperative exercise, cooperative exercise between the Bushfire CRC, the Bureau of Meteorology and the state fire agencies. They all get together in a big conference to produce this map. What we can see here is as a consequence of those drivers, much of West Australia, a lot of South Australia, southwest Queensland and much of New South Wales has a forecast for above normal fire activity due to those unusually heavy growth of fuels and the curing that's occurring in those fuels. Now, over the last month, just over the last 3 weeks or so, this current month, there's been a bit of rain in Victoria, Tasmania and a little bit up the coast here but not just bordering on average there, but some above average rainfalls over the last few weeks in southwest WA. So that's helped the situation in southwest WA a bit, but not really enough to counteract the effect of the last fairly dry 6 months. Now, moving on to tropical cyclones, the Bureau's tropical cyclone warning service is delivered from 3 tropical cyclone warning centres, Perth, Darwin and Brisbane. And over here we've got what looks like a bit of a spaghetti diagram. That's all of the cyclones that we've had from 1906 to 2005, all their tracks plotted. Now there's a couple of interesting things you can pull out of that, what at first cut looks like a pile of spaghetti. One of them is that cyclones start off in the tropics and move south. And as they move south, firstly they tend to move towards the west in upper level atmospheric, in easterly winds. And then they reach a certain point and get caught in the westerly winds and head more in an eastwards direction. So they move south, they come this way, they recurve, and then they start heading the other way. As they do so, they actually affect southern parts of the country as well, particularly southwest WA and southeast Queensland and the northern part of the New South Wales coast. So tropical cyclones are not just a problem for tropical areas, they can affect more southerly areas as well. Sometimes they do that in an obvious way in that they can give you very heavy rainfall. Cyclone Lua, for example, produced some floods through this part of WA last summer. But sometimes it's a bit surprising, particularly in WA. You can get events where the cyclone runs down the coast and you don't get the rain everywhere, but you do get the winds. And cyclones have caused some of the worst fire weather situations in southwest WA, which is a bit surprising. Now, the Bureau has quite a comprehensive set of products for the tropical cyclone service, as well as the outlooks that we've already talked about a bit. They produce every day a short-term outlook for the next 3 days to give information about the probability of cyclones developing over the next 3 days over ocean areas. There's information bulletins for cyclones that are out to sea, and as cyclones start to get closer to the coast, we issue a tropical cyclone watch within 48 hours of an expected impact of the tropical cyclone on the coast. Within 24 hours, we produce a cyclone warning. technical bulletin is used to exchange information between the Bureau and other technical organisations. And of course for the public there's the well-known tropical forecast cyclone map, which I'll show you in the next slide. These are the cyclones that we had last year being a La Nina year. Now, there are only 7 cyclones on that map, only 3 of those made landfall, and that's a fairly small number for a La Nina year where you'd normally expect a bit more. But what actually happened last year is that we had a much above average number of tropical depressions. A tropical depression is a bit like a cyclone that doesn't quite make the grade. We had 29 last year, which is about half again the average number. So there were a lot of intense tropical systems, just not all of them made it to tropical cyclone strength. Here are a couple of pictures from the Cyclone Warning Service. This is that track map I talked about a minute ago. You'll find that on the Bureau's public website, and it shows really a wealth of information about the tropical cyclone forecast. You've got the historical path of the cyclone up to the forecast time, and then these spots show you where the cyclone is expected to be during the forecast. The little number in the middle is the expected cyclone strength on a scale of 1 to 5, 5 being very intense and 1 being quite weak. The circles on that map are the areas we expect to be covered by certain strength winds. This outermost circle is what we call the gale radius. That's the area covered by gale force winds. Gale force winds are 34 knots. They're winds strong enough to damage structures. The next one are storm force winds. That's where the winds get really dangerous, 48 knots, and the innermost one are the hurricane strength winds. Now, as well as that information, we've also got this envelope around the track, and this grey line is the expected path of the cyclone. The envelope shows you effectively the error bars for that. So we're very confident the cyclone will be within that range somewhere, most likely along that track. And this strip along the coast is the watch area in this case. It's the area where we're warning people about cyclone impact. Now that's tropical cyclone Lua. Here's another look at Lua. The black line here is the actual track. The blue line is the forecast track for a 3-day forecast. That's an extraordinary 3-day forecast, particularly since Lua was such a difficult beast to forecast. Unlike some cyclones that take a fairly straightforward path, like tropical cyclone Yasi that was fairly straightforward coming into the Queensland coast, Lua started to move away from the coast. Spent about a day and a half just sort of stalling and going around in little circles off in the ocean before completely changing direction and coming into that coast. So to get that forecast right is quite an extraordinary thing. And not only that, the cyclone track is challenging enough, but cyclone intensity is even harder to forecast. And this is a very good forecast of cyclone intensity as well. 3 days out, forecasting a Cat 3, actually getting a Cat 4 is a pretty good effort. Now, the next 2 maps are the distribution of tropical cyclones. Over here in an El Nino year, and over there we've got in a neutral year. And we've heard from Gary that we're on that borderline between neutral and El Nino. Now, they're not very different from each other, and neither of those are very different from the average distribution of cyclones. So not much of a story different from normal to tell there this year. On the other hand, there are some things we can say. The average number of cyclones in the Australian region is 11 to 12. The preliminary outlook that we have, and that's based on a statistical model driven by the sea surface temperatures and also by the Southern Oscillation Index, is for a 65 to 75% chance of below average numbers. The odds, because of that pattern of sea surface temperatures, the odds are also favouring a later start to the season. So not quite so much of a risk as early season pre-Christmas cyclones. And something to note there is that most of the multiple crossings we've had on the Queensland coast have been in La Nina years. So as we're not expecting a La Nina year, there's a reduced odds of multiple crossings on the Queensland coast this season. Another thing to bear in mind is that not all tropical cyclones make landfall, only around about half of them. The other half stay out to sea, out of harm's way. Now, whatever the season coming up is, it's important to emphasise that you can get a tropical cyclone in any year. So just to prove that, here's one example from the 2009 El Nino year. That's the El Nino year that brought us the Black Saturday fires, so a very strong El Nino year. And here's a microwave image. That's effectively a microwave satellite image looking down through the cyclone and seeing the rainfall bands inside the cyclone. It was a Cat 5 cyclone, did quite a lot of damage. These things can happen any time. Now, a related phenomena is the monsoon onset. The map in the middle is the average start date to the monsoon, where it starts fairly early up in the deep tropics, and it's later and later as you come down the coast. Now, running the model a number of times, that's the POAMA forecast model. We've got the probability of an early onset for this year's monsoon. Not much of a signal, so not much to say over much of Northern Territory and Queensland, but over northwest WA, the wet season is likely to be later than average. And of course, this is quite different from the last two seasons, which have been La Nina seasons and a tendency towards early onset. Again, despite that, flooding can happen at any time. Now, the Bureau puts a lot of effort into its severe thunderstorm service because this kind of thing can happen. These are 10 centimetre cricket ball size hailstones that were collected in Sydney in 1999 after a particularly nasty hailstorm. And this is the damage they did. A little bit under $2 billion damage done in 90 minutes due to things like that hitting tile roofs. All these blue squares here are tarpaulins covering people's roofs. A severe thunderstorm is not an ordinary thunderstorm. It's a thunderstorm that produces hail of at least 2 centimetres diameter, damaging wind gusts, tornadoes, or heavy rain, or rain heavy enough to cause flash flooding. And the normal criteria we use there, it actually varies a bit around the country depending on what's normal, but it's around about the 30 millimetres in an hour. And because this is so important, we put a lot of effort into the warning service where we produce these detailed thunderstorm cell-based forecasts. So once these thunderstorm cells are detected on radar, we've got software that actually tracks them as each radar scan comes in. And we diagnose the speed and direction of movement, so that they all go in as part of the forecast. So here we've got where the cell is, where it's heading, where it's going to be in 10-minute intervals for the next 60 minutes, and the immediate threat zone around that. So quite a high detail commensurate with the high level of risk from severe thunderstorms. Now, these two maps show the numbers of severe storms on a state-by-state basis. Over here we've got the average numbers, and this is the last average numbers over the last 10 years, and these are the numbers for the last season. And what you can really see from both of these is that most of the severe storms in Australia actually take place on the east coast. And that's where the ingredients to make a severe storm really come together. And those ingredients are warm, moist air near the surface, cool, dry air above that, so you get the instability generated, and strong winds coming up from the southern latitudes, which provide wind shear, which helps the storm get really organised and become very intense. So those conditions come together mostly along that eastern seaboard. Other parts of the country, one or more of those ingredients tends to be missing. We care about severe thunderstorms maybe a bit more around the capital cities because that's where most of the people are and that's where most of the assets at risk are. So these are similar numbers to those two pictures, but in this case they're for areas within 150 kilometres of each of the capital cities. Average numbers, again this dominance along the east coast, and the numbers for last year, which was the La Nina year. And they're a bit different from normal. Here we've got the red numbers are greater than average, blue below average, and green more or less average. So we had less in around Sydney and Brisbane last year because of those La Nina conditions, and that's because although there was plenty of moisture, the La Nina conditions meant that the moisture was very deep, so we didn't get the cool, dry air in the upper atmosphere or the wind shear that you need to make those storms. On the other hand, the area around Melbourne had more storms than normal, and that's really because in Melbourne, the limiting, being further south, being drier basically than Sydney and Brisbane, the limiting factor is that moisture in the low levels, and there's almost always enough upper dry air and enough shear. So that's the pattern we had last year. Next year, because we're not expecting a La Nina, it's expecting a return to more normal conditions. The picture over here, or the loop over here, is the radar tracking that severe storm that caused so much damage in Sydney. And you can see this red area here is the core of that supercell. If you look really closely, you'll see some rotation associated with a little mesocyclone. It's a feature we detect in the severe storms. Over here we've got the average annual thunder days around the country, which shows that thunderstorms can happen pretty much anywhere, more in the tropics, but most of those tropical ones aren't as severe as some of the ones we get down that east coast. So as I said before, the outlook for this season, because it's a more normal season, borderline between neutral and El Nino, is a return to more normal more normal numbers. And last year we had a lot of moisture, not the other ingredients, so we got lots of flash flooding type severe thunderstorms, not so much of the damaging wind and hail, so we would have to expect a return to a more normal type of severe storm next summer with more damage expected from wind and hail. And to summarise, the major risk this season from bushfire is the high risk of grassland fires in inland areas due to the heavy fuel growth over the last 2 years and the drying that's seen over the last 6 months. For tropical cyclones, the preliminary outlook is 65 to 75% chance of below average numbers of tropical cyclones, and the odds favouring a later start to the season than average. And severe storms, the story is a return to more normal numbers and more normal types of severe storms. Of course, watch for updated warnings at www.bom.gov.au as severe weather develops. And now I think we have time for questions.
Thank you, John.